Hello and good afternoon or morning. Please, this is the microcontroller and interfacing class, and the course code is btee322, and this will be taught by Dr. Wilfred Ajaja and then myself, Isaac Nelson. So we have two email addresses there. Then the telephone numbers are also there. In case you want to call, you can call on this number. Topics that we are going to discuss this semester will be microcontroller and its interfacing, meaning that we are going to look at the microcontroller itself, define it, the working principles, then the microprocessor and its human behavior. Then we'll come to the microcontroller 8051. We also define that, look at its processor, which is the microprocessor versus the microcontroller. Then we'll look at the 8051 features of the microcontroller. Then we'll look at some block diagram of the 8051. Then some of the manufacturers of the 8051 microcontrollers, then a pin diagram of that 8051. At the same time, addressing models of the microcontroller and how to write programs using the microcontroller. In the real world interfaces too, we'll be looking at that. We're looking at the simple I/O concepts, the LCD interfacing, the ADC 0804 interfacing. Then we'll look at the relay interfacing, then the stepper motor interfacing. So for this course today, we are looking at the microprocessor, and we are saying that it's a multiple purpose reprogrammable digital device and a semiconductor IC, which is able to do multi-purpose jobs or different tasks at the same time. So to that effect, it means that when we talk about the microprocessor, it is a very small chip like you see over here, which has a lot of things embedded in that, and it can be used for different purposes. So the microprocessor works on the following steps. It takes an input data from the outer world. Then what happens is that it also processes it under control of the stored instructions or the programs in the memory. Then it will provide the desired results or output to the outer world. Microprocessors gives the inputs a command. So the input can be your mouse or your keyboard to give the input, which is the command you are given. Then what will happen is that the processing is being done at the processor chip. Then it can be stored either on a hard drive or a flash memory or a pen drive or whatever you want to save on. Then the output, after it has been processed, will come to the output model, whereby we are going to see it on the monitor, or we can also print it out with the help of a printer. Microprocessor and then the human behavior. We'll look at the scan cycle of a microprocessor. It takes an input, makes decision based on the inputs received, and then an output comes out. So as human as we are, In all our lives, we make inputs in our life aspects, we make decisions, and then we bring the output. So assuming you are asked that what is 1 plus 1, that one is in your temporal memory, so you may think you did not even think about it, then you say 2. But then when they say 14 minus 5 plus 2, that one you have to think about it, then give an answer. So you take the input, you make a decision based on the input that you have received, process it, then an output comes out. So when we look at the microcontroller, it was introduced in the 1981 by Intel Corporation. And we say microcontroller is a programmable digital processor with necessary peripherals. Peripherals in the sense that we have both microcontrollers and then microprocessors, and they are very complex sequential digital circuits meant to carry out jobs according to the program or the instructions given to it. So assuming we have this as our microprocessor and then this as our microcontroller, so what happens is that the microprocessor, we have the CPU, we have the RAM here, which comprises of the data bus and then the address buses. So therefore we have the RAM, we have the ROM, we have the input output ports, we have the timer, and then we have the serial COM port. So comparing it to the microcontroller also has the CPU, has a RAM, has ROM, has an I/O, which is the input output, and it has a timer and then a serial COM port. So in this class we are going to look at the features of the microcontroller 8051. So these are some of the features you can find on the microcontroller 8051. And then the local block diagram of the 8051. We have the external interrupts, we have that is interrupt control, then we have the CPU, and then the oscillations are being controlled at this point. So on the chip ROM for code, at this point the bus controls are being used to control the various signals that we are receiving. Then on the chip, the ROM is what is going to help us with the coding. Then the on-chip RAM keeps the information so that we can access later, but the ROM keeps it temporarily. Therefore, the I/O input where we can connect our address or the data points. Then we also have the timer also connected at this point to also do its own job based on the desired output that you're going to give to it. Then we also have the serial port where you can connect to external source. So we have a lot of manufacturers of the 8051, and some of them are the Intel, the Atmel, the Philips, Dallas, Motorola, National, then the Infineon. They all manufacture microcontrollers. So this is the pin diagram of the 8051. On this note, we'll end the class here. Then further questions will be done on the platform whilst we enjoy the rest. Kindly subscribe to the channel so that you will receive the next class. Thank you.